sometimes it's necessary to work backwards in a normal probability problem. So for example, sometimes we may know the probability or the area beneath a normal curve, and we want to find the z-score that has that area underneath the normal curve. In other words, we're going to work backwards. So for example, if we look at part A here, we want to find the z-score such that the area under the standard normal curve to its left is 0.10. So visually, we have the standard normal distribution. So the mean here is 0. We're looking at the standard normal distribution. We know that the area to the left of a particular z-score is 0.10. So this is 0.10, and we want to know what is the z-score that has that area to the left. Now we can find this a couple of different ways. One way is we can use the tables. So if we want to use the tables, then we have to think of the tables sort of in reverse of the way that we used them previously. So for example, previously we had the z-score and we looked up the area inside here. So in this case we have the area and we want to look up the z-score. Okay? So the area to the left, which in this case is what we see in the guts of this table, is supposed to be 0.10. Now 0.10 to 4 places would be 0.1000. So I want to look in here and find 0.1000, or the closest thing to it, and then find the z-score that corresponds to that. So looking inside this table, I see that we have 0.1003 and we have 0.0985. So if this table had more detail to it, then 0.1000 would be somewhere between these two values. So the closest thing we have to 0.1000 is 0.1003, and that corresponds to a z-score of negative 1.28. So this z-score right here would be negative 1.28 approximately. In part B, we want to find the z-scores that separate the middle 96% of the standard normal distribution from the area in the tails of the distribution. So again, here we have our standard normal distribution, okay? And so we're wanting to find the z-scores that separate the middle 96% from the area in the tails. So in other words, we're going to have two z-scores. They're going to be the same value except opposites. So this is going to be a z, this is going to be a negative z. So let's go ahead and call this one positive z. And we want this area in between to be 0.96. Okay? So we want to figure out what these z-scores have to be in order for that area to be 0.96. Now, if the area in between negative z and positive z is 0.96, then the area out in the two tails altogether has to be the other 0.04. 1 minus 0.96 is going to equal 0.04. And half of that 0.04 is going to be in this tail, and half of that 0.04 is going to be in this tail. Well, half of 0.04 is going to be 0.02, and this is also going to be 0.02. So this area and this area each is 0.02, okay? So now these two values are going to be the same value, except this one's going to be negative, this one's going to be positive. So if I find one, I really have both, okay? So again, I'm going to use the standard normal table, and before I pull that in, I'm going to be looking at 0.02 as 0.0200. So I'm going to be looking inside the table to find 0.0200, or the closest thing to it. Okay? So 0.0202 is right here, and 0.0197 is right here. So 0.0200 would be in between these. Okay? Now we're going to go with what's closest. 0.0202 is a little bit closer to 0.0200 than 0.0197 is. So this is going to match up with negative 2.05. So this value here is negative 2.05, which means this value here is positive 2.05. So the two z-scores that separate the middle 96% of the standard normal distribution from the area in the tails is negative 2.05 and positive 2.05. Now we could also use the calculator to figure out these values. So if I pull in my calculator, I'm going to go to second and distribution, the same place where we've gone previously. But this time, instead of using the normal CDF command, I want you to notice number 3, the inverse norm command. Now here is how the inverse norm command works. We're going to type in the inverse norm, and we're going to put in the area to the left of the value that we need to find. And then we're going to put in the mean, which for the standard normal distribution will be 0. And we're going to put in the standard deviation, which for the standard normal distribution is 1. Okay? So in part A, we know the area to the left is supposed to be 0.10. So I'm going to do inverse norm, 0.10. The mean is 0, and the standard deviation is 1. And that's going to give me the result. So now when I use my newer calculator here, I type in the area. So the area is 0.10, the mean is 0, the standard deviation is 1, and I have the area in the left tail. So I tell the calculator the left tail and paste. Okay? So I get this command on my screen. Now if you have an older calculator, you don't get this option of left, right, or center. You always will have the area on the left. So if you don't see left, right, and center, then it's always the area to the left. So when I hit enter, I get the negative 1.28 that we found previously. So this is negative 1.28. Okay? Now for part B, I can do this problem a couple of different ways. Now if you have an older calculator, we have to do this pretty much the same way that we did this one before. So I can do inverse norm. The area to the left of my negative z-score is 0.02. The mean is 0, and the standard deviation is 1. So if I pull in my calculator, inverse norm, the area is 0.02, and that's in the left tail. So when I hit paste, that gives me the negative 2.05 that we found. Okay? On these newer calculators, we have other options. So we could have done this problem a little differently. So if I go to inverse norm, I also know that the area in the center is 0.96. That was given to me directly. So I could have also have chosen 0.96, and I could have chosen the center option. And when I paste that, notice it says center, and so I get negative 2.05 and positive 2.05. So it gives me both of those values. If you have an older calculator, though, you don't have that feature on your calculator. You have to do it the way we did it the first time. So we have found the same results that we found by hand with the calculator. Now we also have an option of doing this with StatCrunch. And the StatCrunch normal calculator is actually quite amazing. So I'm going to pull up the normal calculator. So I'm going to Stat, Calculator, and Normal. Okay. So I have in here the mean of 0 and the standard deviation of 1. Okay. And so this calculator works both ways. If I enter the appropriate z-score, then it gives me the probability. If I enter the probability, it'll give me the z-score. So in this particular case, I'm looking for the area in the left tail. I want that to be 0.10. So the fact that it's the left tail means I'm going to make this less than. Okay? And so I type in the 0.10, but I type it out here. And when I say compute, it gives me the z-score that has that area to the left, which is negative 1.28. Okay? In the same way, I could do part B. So in part B, we wanted the area in the center to be 0.96. which we figured means the area in the two tails has to be 0.02. So I could come out here and type 0.02, and when I say compute, it gives me the result of negative 2.05. Now I could have also changed this to greater than and entered 0.02, and that would give me the result of positive 2.05. So it works very well. Or I could have gone between, and I could have come here and typed in the 0.96, and when I type in the 0.96, it gives me the negative 2.05 and the positive 2.05, so we get the same results. So you have lots of options to use when you use the StatCrunch calculator. Okay, so here we figured out in 3 different ways, by hand, with the calculator, and with StatCrunch, that we can work backwards. If we know the area beneath the curve, then we can figure out what the z-score has to be that corresponds to that area.